We out here. Okay. We out here. What up? What's going on, everybody? Appreciate you for being here. Go ahead and grab my headphones. Where goes that? Where are my headphones? In my drawers. No, not there. What's up, everybody? You're having a good day today. Get the stream loaded up here. Here we go. Nice. Okay, cool. We loaded up. Hey, what's up, Paul? I was working in Zig. Nice. A 5-hour session. Nice, dude. Grinding. All right, everybody. What's going on? I hope you're having a wonderful day today, or this evening. It's kind of like a little bit later than I normally get on, but we're on nonetheless. I wanted to hop on here and maybe take a stab at a couple of these at the exercises here for the end of chapter 5. So jumping back into C Programming, a Modern Approach, chapter 5. This is going to be the exercises here. All right, let's go ahead and get into this. So let's go open an integrated terminal. And let's do this. For I in we'll say 1 to I think it's 11. I think we say we're just gonna make dir, and we're gonna make dir for chapter 5 exercise, yeah. And then we're gonna put here there we go. Now let's just go into here and let's just touch chapter 5 exercise 1.c. Okay, cool. Nice. Look at us using the terminal. Okay, let's get rolling here. Okay, so we're going to take a stab here at number 1. The following program fragments illustrate the relational and equality operators. Show the output produced by each, assuming that I, j, and k are int variables. Okay. Let's go ahead and do int main void. We'll open this up. Let's do a comment. We'll have our A. We're gonna have int I, j, k, right? And then we're gonna say is I is equal to 2. J is equal to 10, and K is equal to 1. No, sorry. J is 3, and then we're going to go K is equal to I times J is equal to 6. And then we're going to call printf, and we're going to insert in here the int value for K. So output. So what's going to happen here is we have 3 variables that are integers, I, j, and k. I is a value of 2, j is a value of 3, and k has a value of I times whether or not j is equal to 6. So this doesn't assign j to 6. This says, it raises kind of like a question. True or false, is j 6? If it is, right, it'll be 1. If it isn't, it'll be 0. So in this case, j is not 6, so this value will be 0. So k in this case, I think, will be 0. So if we here we go. Number 1, chapter 5. Number 1, chapter 5. Oh, it's not programming project, sorry. Exercise. Oh. We need to include our standard.io.h header file. But let's go ahead and do these other ones first before we do it, and we'll just do it all at once. So now we have I is equal to 5, j is equal to 10, k is equal to 1. Right, and we're going to call printf to the integer, and we're going to insert into there k greater than I, which is less than j. Okay, so what's this going to do? So this is going to evaluate, I believe, like from one of our examples in the text, that these evaluate to left to right. Hold on one sec, where are you? Yeah. Okay. So these arrange left to right. Okay, so what's going to happen is that these are going to be grouped and evaluated. Is k greater than I? Well, k is 1, I is 5, so no, it's going to be 0. So is 0 less than j? Well, yeah, this can be true. So I think that this is going to do the output is going to be 1. Let's try C. I is equal to 5, j is equal to 0, and k is equal to -5. We're going to call print f and do it to the %d here. I and percent j or k. Okay. So this is going to say I'm going to assume like this is going to be like are I and j the same value? Is that what this is saying? Like, oh, are these the same value? If so, true. If not, then false. Let me look up I and j. Logical AND operator. Two operators. Result is 1 if true. Both I and j are non-zero. Oh, non-zero. Means any non-zero is true regardless of sign. Okay, so it's a non-zero, not whether the same or not. Okay. So in this case, I and j, this results into both non-zero. No, this is 0, so this is 0. Now this will be either or is non-zero, which is true, so this will print out to 1, I think. So now if we have I is equal to 1, j is equal to 2, and k is equal to 3, we call printf to the decimal, or the digit, and we're going to evaluate this conditional. Okay, so I is 1, j is 2, k is 3. We're going to first evaluate this guy. So I is less than j. I is 3, j is 2, so this will evaluate to true. So this is 1. Now 1 and 3 evaluate. Both are both greater than 0, are both non-zero. So this will evaluate to 1. Right? Let's try it. Let's add in some \n here though, so we get some distinguishing prints. B. Oh. K greater than I, which is less than J. Comparisons like X less than or equal to I know they don't have mathematical meaning. But it's like, my book has it here. Okay, so hold on. And see operators on chain like they do in Math or Python. Oh, so did it still compile? It just gave us this little warning. Oh, okay, it's not an error. Okay. So it's still compiled. So now let's go and do this /chapter 5 exercise 1 exe 1111. Oh shoot. Okay, so we got one wrong. We got the first one wrong. A. Okay, so this is going to say I is equal to 2 and j is equal to 3. This is going to evaluate I thought that this would evaluate j equals to 6, and that would be false. So it'd be 0, and then I times 0 would be 0. Let's get some feedback here. And C, the multiplication is higher precedence. Okay, so it does that one. Oh, gotcha. Okay, so that's where I messed up. So the multiplication is higher precedence than the is equal to check operator. And so it'll do this first. 6. Is that equal to 6? Yes, and that'll be 1. Ah, okay. So we'll make a little note here and say multiplication has higher precedence than what is it called? Is equal to. We'll just do this. Okay, so that was the only one we got wrong, was A. Dang it. Because I didn't realize that I forgot that the multiplication is higher precedence than this one, so this would evaluate to 6, and then we'd have 6 is equal to 6, yes, and so k would equal to 1. I was thinking that it would try to do this first, and that would say, oh, that's not true, this would be 0 times I, but not the case. We got the other ones right. Cool. Let's go ahead and move on to number 2 here. Let's go ahead and touch chapter 5 exercise 2.c. Let's get into this. Let's see who's in here. Hey, hello, how's it going? Yeah, Prism, I shaved my beard. How's it going? Welcome. What's going on? My lady friend was complaining. Can you recommend me some coding programs or games to improve? I don't know, that's kind of hard, honestly, because it's pretty difficult to like give recommendations, because in reality, if it's not something that you want to, it's something you want to do, most likely you're not gonna like finish it. That's from like my experience, at least, is like I have a hard time finishing things I'm not really like that passionate about. So my advice would be to find something that you actually enjoy doing outside of programming and try to just convert it into programming. Okay, let's try number 2 here. The following program fragments illustrate the logical operators. Show the output produced by each, assuming that I, J, and K are int variables. Okay, so let's go ahead and include our standard IO.h, and let's go int main void, and let's open this up. We're going to do A, and let's do I is equal to 10, J is equal to 5. What we're going to do is call the printf function, and we're going to insert the decimal value, or the integer, and we're going to do not equals to logical not I less than J. Okay, A output. Okay, so A output is going to be, well, I is not less than J, so not less than J. Does logical not just determine if the entire thing is how do you spell not? Not K-N-O-T or N-O-T or logical. It's probably not like this. It flips the truth value of an expression. Not false becomes true. Okay. So it'll evaluate this, right? That evaluates to I is actually greater than J, so that actually evaluates to false. So this is 0. So not 0 would be 1, right? So this produces 1. I equals 2. J is equal to 1. We're going to call printf, and we'll do to %d, and we'll do exclamation I plus exclamation J here. Okay. So we'll say precedence. Okay, logical not has higher precedence. Okay, so actually the logical not would happen first here. So this would go to, okay, I is greater than 0. So this would go to 0 instead of being 1. And then what would happen? Well, this would be 0 is, and so this would evaluate to 1. Right? You say not not 5 is not true, it's false, which would be 0. Not 0 would evaluate to not false, which is true. Okay, so any value that isn't non-zero is true, right? Any value that is 0 is false. That's how the bools get evaluated in C. Okay, so then this happens first, evaluating to 0. Or I becomes 1, this evaluates to 1, right? Because, no, oh my gosh, so I is 10. Not true, so false would be 0. 0 is less than J, so this still is true for this statement. B. Not I and not J. So I is 2. So that would be not I would be 0. Not 0 would be 1. Plus not 1 would be just 1. I think, hopefully. I is equal to 5. J is equal to 0. And K is equal to -5. We're going to call printf and do %d. And we're going to input I, logical and, J, logical or, K. Okay, and then C output. What's going on, SS low? W grind, dubs. Hey dude, how's it going? Okay, so Alright, so this would just get evaluated here. So are I and J both positive or both true? No. So this is 0. Are either those 0 or either one non-zero? Yes. So printf will evaluate to true here. Are these going to be all 1 again? I is equal to 1, J is equal to 2, K is equal to 3. Call printf, and we're going to printf to %d, and do I, which is less than J, which is logical and, or logical or K. So this is going to output, let me guess, probably 1. Okay, so let's look back at our precedents here. So relational has higher precedence than logical or. So the relational will be evaluated first. So I being 1, J being 2, which is true for this evaluation. So that's 1. 1 or that is, I think that's 1. See if I get this. Okay, so we got some errors here. Oh. Okay, there we go. We got that warning. That's fine though. Now we're going to do / chapter 5 exercise 2 exe 1111. Perfect. Let's just add some \ns here to clean it up. let's try that. 1, 1, 1, 1, 1. Nice. Hey Lance, how's it going? Appreciate you coming in. Output 1, 1, 1, 1. Nice. Got it all right. Welcome back in, Lance. Thanks for coming in, dude. Okay, let's go ahead and crack open number 3. Let's go touch chapter 5, exercise 3. Let's see here. Okay. Bro, how are you always so motivated? Where do you get your motivation from? Honestly, dude, just are you in college, Lance? Because it's probably, dude, honestly, just boredom. I got nothing else to do, man. Like, what else would I do? Just play video games and really walk away at the end of the day with like nothing. At the end of the night with nothing productive done. Like, I don't know. I feel like I've got to do something to get myself out of like the spell of like 9 to 5 or something, or I don't even know, like just to get skills that can translate to out of ways to make income. I don't know, I'm just motivated to try to find ways to get skills to make income outside of work or whatnot. And I don't know, I in my 1 year of streaming here, I've only made $100, so, but it is something. It is something. So it's way better than nothing, that's for sure. But it's a lot of hours we've been putting here, but still I've been getting that and the value of programming too, so it is kind of a win-win. But it's definitely I don't have like any friends out in person. I have some friends from back home and like on Discord and stuff, but like I have like one coworker that I'm kind of close with, but he's like grown and has a baby and stuff, and so it's like kind of different. I'm like, it's whatever. Okay, whatever. Sob story me. Boo boo boo. What's the world's tiniest violin, Mr. Krabs meme? Okay, let's declare some variables. So int I, j, and k. And then let's go ahead and get into this code here. Show the following program fragments illustrate the sort of circuit behavior of the logical expressions. Show the output produced by each, assume that I, j, and k are int variables. So I is going to equal 7, j is going to equal 8, and k is going to equal 9. We're going to call printf. We're going to do it to %d, and then we're going to do I minus 7, and j plus plus less than k. Right? And then we're going to print the values, I'm assuming, of all of them, yeah. %d, and then we're going to do I, j, and k. Okay, so let's predict the output here. So A output. So what do we think is going to happen here? So we need to show this short-circuiting behavior. So this is postfix. So J is not going to increase here within this line. It'll increase after the print statement. So, and I'm pretty sure it'll increase after the original value of J will be used to evaluate here. So I minus 7, well obviously this is going to be 0. So this is non-zero, this is 0. Now J, we're going to use the original value, is less than K. That equals to true, so this is 1. So this actually evaluates to so this is a 1 and this is 0, so this actually evaluates to 1, so this value here. And then we're going to print out the values of I, which is 7, k is 9, and then j increases to 9. So 799. I think that's what it'll be. Let's keep going. We'll check them at the end all together. Hey, Jimmy Boats. Don't we live in SF? I live in the Bay Area. NorCal area. Okay, I equals 7. J equals to 8. K is equal to 9. Okay, we're going to call printf, and we're going to do %d space here. I less than 7. And j plus plus less than k. And then we're going to call this printf again. And we're going to do b output here. Okay. So in this first one, oh, I'm trolling. I did the wrong one. Seven, 8, 9. I minus 7. J plus plus less than K. Okay, so this is A. My bad. My bad. Okay, then we're gonna do this. This is gonna be B. Sorry. So B. Oh. Wait. Yeah, this is B. Uh-oh, my caps lock stuck again. No! Get out of there. I just trimmed my nails too. There we go. This is B. A is 3, 4, and 5. And then we do I less than J. So just because this is false, I'm going to go back up to the notes on the short circuiting here. However, if I is equal to 0, then the attack expression must be false. So there's no need to evaluate this one. Right? So if this, oh, because this is OR, it will evaluate. Okay. Because it can have a possibility, right? If this were to be, okay, so this is and. Got you. So this is actually going to be 0 because this goes to 0 and requires both of these to be true. This is a 0, this is non-zero, and so this would evaluate to 0. Now here, the A output here would be, so 3 is less than 4, so this evaluates to 1. J increases right here to 5, and 5 is not less than K, which is 5, so that evaluates to 0, but this is 1 here. So this evaluates to 1 because it just is OR for the entire expression. Okay, I think we're good. Let's keep going. We'll check at the end. Honestly, I don't really know if it's free but I'm pretty sure it's AI generated music. It's the Luna Lounge on YouTube. There's quite a few of these like recent kind of creators that have just kind of been putting out like AI generated music. So I'm not really sure like what kind of copyright claims can come from AI generated music. It's kind of interesting. I've been listening to this whole time to his mixes, and I'm sure it notifies him, and he hasn't said anything. So, if anything, he'll turn on the revenue share if he wants it, but he hasn't done anything about it. If you're not starting a company, why live there? I'm in biotech, so it's just a big biotech hub, either here or like Massachusetts or like New Jersey. But like all three of those places are all high cost of living, or very high cost of living. So it's just doom or gloom pretty much anywhere. Biotech, unfortunately, it's just like, I don't know. It's like maybe in this area, maybe not like Boston or New Jersey or something where like there's less of a tech influence. So maybe wages are a little bit more fair to biotech people. But the tech influence here just throws us under the bus, man. We get priced out bad. Okay. So where was I? But it's kind of difficult because I honestly don't think I could really get work anywhere else. Like the market's just so bad in general across all fields, especially STEM, these fields right now, even with experience. Like I don't feel like there's any other place in the United States I could get work at. That's the thing. It's like I'm like really like I honestly feel pretty stuck. Okay. So C here, printf %d, and we're going to do the evaluation of this statement. Okay. Oh, whoops. We're doing 3. We're on 3 here. 3C, my bad. I is 7. J is 8. K is 9. And we're going to evaluate. Let me just take this guy here. C, printf d, I is equal to J. So that sets the evaluation. That sets I equal to J there, and I equal to K. Will this throw you an error? Can you not set a value and then also in the same statement? So if we were to think about this, it would either raise an error, right? Or if it were to go through, it would set I equal to j. Right? Which in this case, everything is positive. So it doesn't really matter because this whole statement would be 1. So we're definitely gonna need some insight, a little bit more help with this one. But my assumption is that this would print out 1. And if it didn't print out an error, and the values, I would be equal to I stays the same at 7. I gets replaced from 7 to 8. J gets replaced as the value of k, which is 9. And then k remains as 9. Okay. Let's keep rolling here. We're going to do our checks all at the end here. Almost there. I equals to 1, j equals to 1, k equals to 1. We're going to call print f. I'm going to do %d space percent, or per quote, plus I plus j ampersand plus k. Getting crazy with it. I'm getting crazy with it. Okay, so what would this prediction be? Okay, so this first one, I would be increased in line, and so would j, and so would k. So j, I, and k all increase. Okay, this is an ampersand, this is or, so this expression, gosh, dude. This expression that would not like short circuit because either could be true, so it would evaluate to both sides. Now, I increases to 2. J increases to 2, and K increases to 2. Well, I and J are both non-zero values. So this first portion evaluates to 1. Now, 1 and K, which is 2, are both non-zero values. So this whole expression evaluates to, I think, 1. And the values would all just be 2, 2, 2. Let's get some feedback here. Let's try it out. Oh. As the space is there to kind of print them both together. Okay. /chapter 5. Oh no, we need to compile it, by the way. Compile this boy. Oh, we forgot to do that other part. Well, we got it kind of spoiled for us. We'll try again here. Hold on. So 3 is less than, so J increases in line here. So this would happen first, right? According to our precedence chart. Oh, where did that go? I think where'd that go? Bring back the precedence order. Yeah, increment. Okay. Wait. Postfix. Give me the list you gave me earlier. Yeah, okay. So J would increase, right? And then this would take place. So that would evaluate out to 1. J increase here. This evaluates out to 0. So 1. So I is 3. J increased to 5. K is 5. Zero, 1, 2, 4, 5. So does that not... Prefix. Leave the... Operation increment first, then use the value. Variable cells updated immediately. So J is still being seen as 4 here. If it's used in if used in expression, is it term? Because like, here's my example. Evaluate here. Just 3 less than 4 is true. Oh, so you don't do the plus plus first. That means that this doesn't run. So the plus plus doesn't have higher precedence. Operator precedence versus evaluation order. They are related but not the same. Prefix has higher precedence. That means that in an expression like this, J++ happens before the comparison. Has a lower precedence, so normally this is grouped. Oh, but you still read, but the short circuit evaluation can override execution. Even though the plus plus is higher precedence, it won't run at the left side of it is true. So it still will read it left to right. For these. So these logical statements read left to right, unlike some other code. Left to right evaluation for the short circuiting. The and logical OR always evaluate and left operand first, only if needed. Okay, so even if you had the plus plus take place, right, it technically like wraps parentheses here and then parentheses around that expression and then here and then around the entire thing, and then you enter and read left to right. Okay, but like it kind of has like distinct sub precedences on either side. So the expressions on either side of the logical have like a sub precedence nested in their side scopes. Each side of the logical operator is like its mini own expression. Operator precedence applies in that sub expression. Okay, so I thought it was evaluating the entire like expression like string as once, seeing the plus plus happen and then going back through, but no, it reads left to right and then evaluates these on a sub level. Okay, so knowing that, let's kind of go back through here. Let's take a peek at this other one here. So 7 minus 7 results in 0. Well, and requires both of these to be non-zero, so the right side isn't evaluated. So we'll print out 0, but our j isn't incremented, so that will be 8. Let's check out this one here. In this statement, I is increased. So hold on, yeah, this one's probably going to be different too. Let's take our new knowledge now and apply it here. So I is increased to 2 and used directly here. I is increased to 2, which means that we will evaluate the right side, because either one. So we know that the statement's going to be true, so we will evaluate the right side. So j will be increased to 2. And making this entire statement 1, because these are both 2. I mean, either or of them have to be either or have to be greater than 0. Now this is both of them have to be non-zero for it to be true, right? And so this is 1 here for this expression, and then this would be we need to evaluate the other side. So that would be, so it would be 2, 2, 2, no? No, 2, 1, 1. And 8, 8, 9. Oh crap, I suck at this bad, man. Yeah, the 1 increases to 2. Either or be non-zero values. Well, we know that that's a non-zero value because I is 2. but J is not increased, and neither is K. Why? Oh, because we already know that one of these is true given this logical OR. So we don't need to evaluate the other side because we already know the entire statement is true. It doesn't keep going through when it gets an answer that satisfies the overall statement requirement, right? The and is the only one that will require us to go through both sides if the first statement is met to evaluate the second statement. But as soon as we hit a statement that's true for the OR, it's done. The key concept of short-circuiting, right? And that's why we can have these side effects not take place, because that satisfied, this left side of this OR was satisfied, so the right side didn't need to take place. So this would be 1 and 1. Now let's go back up in here and look. So this would be, I would be 8. This satisfies this because this side of the OR is non-zero. So the other values this would remain 8 and that would stay 9. Okay, cool. I get that now. Let's try that. 0, 1, 3, 4, 5, 0, 7, 8, 9, 1, 8, 8, 9, 1, 2, 1, 1. Perfect. Boom. Let me refill my drink. A little bit of like soda water. Like water with leftover soda remnants, not sparkling water. Let's catch up on some chats. There's lots of chats that came in. I was focused there though. Hi Michael, just found your channel. Mathis says, great stuff, man. Are there any specific biochemistry projects you intend to do in C, or are you just learning the language for fun? Yeah, we started off, we did some projects in Python, some biochemistry related projects. We did absorption spectroscopy simulator, as well as the paper chromatography simulator. Both of these were like labs that I did in my undergraduate, like physically, so like it was cool to kind of convert them into code and simulate them. My hair's going crazy tonight. What is going on? Yeah, it should be fun to see what we can do in C. Maybe we can try something more like physics related and get something faster. I don't know. It'd be kind of cool. Yeah, I don't know. We'll find out. Something like physics and biology together. Maybe we can like model like the electron transport chain or something. That'd be pretty cool actually, and like make a visualization, or I don't know. Hey Mark, how's it going? Thanks, Mathis. I appreciate it. Jimmy. I like to think of condition as separated by that and that going left to right. Anything between them, you can think of as in parentheses. Hey, what's up, Light? How's it going? Hey, what's going on, Blastoderm? You guys were kind of giving me tips there. It sounds like we figured it out though. All right, let's keep rocking. Okay, here we go. Let's touch here, chapter 4, exercise. That's not chapter 4, chapter 5. Exer. 4.c. For those that are new, my name is Michael. I appreciate you guys for joining me. I got a degree in human biology and a minor in chemistry. And I work full-time as a biochemist, or formulation chemist, where I make biological controls. And I've been teaching myself after my 9-to-5 job for a few hours a night for the past year and a half, almost every single day, computer science and programming. Mainly starting off in Python, and did some cool stuff in incorporating data science and biology and chemistry into that. And now we're moving on into C to kind of dive deeper into actually computer science and programming. So thanks for being here, everybody. If you guys are new, consider following along. It's been a lot of fun so far. Appreciate all you guys. All right. Number 4, write a single expression whose value is either -1, 0, or +1, depending on whether I is less than, equal to, or greater than j, respectively. Okay, so standard io.h, and let's do int main. We're going to do a void parameters. So whose value is either -1, 0, or +1, depending on whether or not I is less than, equal to, or greater than j, respectively. Okay, so we want a single expression that does this. Int I and j, we call printf. We're going to insert %d, and what we're going to do is call, okay, so we need to figure out a way here. Let's think. Either 0 or 1, +1, but also -1, less than, equal to, or greater. Okay, so if it's less than, it's -1. If it's equal to, now I don't think we're not supposed to do if-else chains yet, right? So we're still in with these kind of logical expressions, I believe. I'm trying to think of, like, is there a way we can use short-circuiting, or what we've learned with these past few problems, or are we kind of moving on? Well, this is, what do these symbols mean? I forgot what the symbols mean on the questions. Can we chain a combinatory expression together like this? Like something wild? Is it wanting if, or is it wanting us to stick with what we've kind of done so far? Yeah, this is still in 5.1, which hasn't introduced the if statement yet. But it did introduce compound statements. I'm just trying to gauge what it, oh wait, no. Yeah, so here, logical operators. So if you just return, so let's just say that I is equal to 1, j is equal to 2, right? If you just return I less than j, but no, it's wanting, okay, so maybe we can chain these creatively together, but the thing that's throwing me off is the negative, kind of. Right? Because our logical expressions never return so if j is less than, right, that will short circuit. What if we short circuit that? Right? So if j is less than, return, what does it want for less than? Okay, come on. Sorry, getting lost here. -1. Maybe I think I'm just way overthinking this. I'm trying to think of a way to like chain these things together with plus plus or maybe with a minus minus now, right? So if we do like, well, actually we're not returning a value of I or j, but no, we're doing evaluations on them. So by evaluating I less than j, if that's true, that'll return 1, which is not what we want. And the operators never return a negative value unless we were to actually reduce it at the very end. So let's say that you're equal to, if you're equal to, right, that'll give you a value as 1 for true. Dude, I'm trolling, man. Maybe I don't think maybe we aren't supposed to do the negative is what's throwing me off. Okay, so if we have I be greater than 0, or I be greater than j, then we want it to be +1. So let's have, if I is greater than j, let's have it return the +1, right? That'll short circuit. So if I is greater than j, that will be 1, and that'll short circuit this and return that value, right? Now, if that doesn't happen, we will decrease, but I don't want to like decrease the value of I. What if I just return a value like a variable. I don't want to decrease these variables because they actually have nothing to do with the answer here, other than the fact that they have conditional, like, right? The actual values themselves don't decrement down to these. So that'll return 1 if that's true. If 0, it'll go and look for the other one. So we need that. We need this to return 0 on the right side. So on the right side, if we want the right side to return 0 to satisfy the middle constraint, meaning that it is equal to, we want to say that it's not equal to. So if I is equal to j. So if I is equal to j, right, that will return, which in this case it isn't. So that'll return 0. Or no, that'll be 0. And then this entire thing will be 0. Right? And then how do you return a -1? Okay, let's first go over this scenario 1 where I is less than j. Okay? So what happens here is that I is less than j, so this is not true. So this is 0. Because this is 0, we need to move forward to try to figure out if the right side will satisfy this OR. If this is true, meaning that I is 3 or something, then this will return 1 right away. So let's stick with our scenario here. No, but if they're equal, that'll evaluate to 1. This will evaluate to 0. This will return. So we need to take this and reduce it by 1 if it gets through. Something like we have to take away 1 somewhere, right? So it's not j minus 1. It's this guy minus 1, right? But we want it to take place after that evaluation occurs. Because I don't actually think I want to put the parentheses. This will evaluate to 0. This will evaluate to 0. meaning that I is less than, so we need to reduce 1 from this evaluation. So I think what we do is put parentheses around this. Okay, now let's have this scenario of 2 and 2. This is not true, so 0. This is true, so this is 1. So this entire function is 1, reduced by 1, so that's 0, which is the middle statement. Now let's say where I is 3. If I is 3, right, then j is 2, this will evaluate to true. But we don't want to subtract 1. I want to print it. Let's see what happens. I don't think that's right here, but I'm curious. So we'll see what happens with this one. We got 0 here. So this should have been 1. So I think that this is hitting here. It's always subtracting. Now if I do 2, getting 0. And now if I do 1, we should get the -1 here. Yeah. Okay, so we just need to figure out how can we only have this -1 take place Can you put like the parenthesis there around that operator? Like that'd be kind of crazy. No. Because I don't want to reduce. So if we're going to subtract 1 no matter what, then we need to have it lead by 1. So, because in this case we were subtracting 1 always, right? Right. That was what was happening here, and so our high case wasn't working. Let me fix this. Now, what if I said... But they said they both have to be true. If I is less than, equal to, or greater than j. So if I is greater than j, this is going to return 1 right off the bat. If we do the or here, right? This will return 1 right off the bat if I happens to be greater than j. If I is less than j, 0 will be here. And we need to determine if I is equal to j. if that is true, this will be 1, making this entire value to 1, returning 1. But how can I get this -1? So I is greater than j, or how can we get the -1? That's what I'm struggling with, is the -1. Don't want to return. The -1. Because the logical and illogical OR only return a value of 0 or 1. So I have to reduce somewhere, right? I have to reduce somewhere. Well, then this whole thing will evaluate. So this evaluates to false, so it's 0. This evaluates to 0, so this is 0. Ah. This whole thing. And if I have so what if I What's up, Jimmy Boats? Yeah, I don't think we're allowed to use the ternary operator here. It's not in section 5.1. And this question 4 is in 5.1. That's why I haven't tried it with the ternary operator yet. So I'm trying to reduce this down. So this will give me the cases for when it's equal to and greater than. Right? If it's greater than, it'll just return 1 right off the bat and short circuit. Oh no. But then we have to reduce this by but I don't want to reduce the value itself by 1. I was thinking, like, what if we just give everything like a +1 value and then reduce down like after each check? It's like, okay, so I is actually, is I less than, or if we start, I don't want to have to do like a variable that we decrement down. And check like, So in this case, this would return back a 0. So if I take this, okay, 0, and I compare this against what if I like, see my idea was, what if I place like a minus right here out in front and return back this, no, because that wouldn't work either. So here, this would give us, in this case, 0, right? And then in this case, this is also 0, meaning that this entire statement is 0. Now, because it's still 0, the thing is Wait, maybe we have to say it's not equal. So if it's not equal, it'll return 1. So if it's greater than, right, it'll return, this will be 0. If it's not equal to, this will be 1, making this statement 1. When it shouldn't be 1, it should be negative 1. So what if we start off with the not equals? What if we say if I is equal to j, right? And right, so if I is equal to j, well, what if it's not? Well, it's going to return 0 right away, right, which satisfies the condition we're looking for, right? So if it's greater than, if I is greater than j, we need it to be positive 1. So in order for this statement to come true, if I is equal to, well, if I is equal to, actually that wouldn't work because we'd have to have the other side be true, and it couldn't ever be true because I is already equal to j. So that would not work. So if I is not equal to, and so I don't think and is our player here because the and makes it so both of them have to be true or both of them have to be false. And so it doesn't really help our case here for kind of this triplet that we're facing. So I think we stick with the or. So if I is equal to j, well, in this case it's not, so that's 0. Or so in order to return positive 1 in this case, I would have to be greater than j, right? So this would return 0, this would return 0 in this case, meaning that we need to return a separate value. So if I is equal to j, which in this case it's not, that'll be 0. If I is greater than j, well, in this case it's not, that'll also be 0. Meaning the result of this logical or will be 0 because both of these values were both 0. So if we want to subtract so what if we did here less than, oh, I get it. We have to do a less than the and of, we have to do less than either the and 0 or 1 of a condition, right? So this is going to be the subtraction that takes place here, right? So, and it's going to be either a subtraction of 0 or 1 if this condition is satisfied. So subtract now we need to find a condition of 0 or 1. So something like, right? I don't know. I think we have to subtract something, either a 0 or a 1 in this yellow parentheses. Now, how can we get 0 or 1? Okay, well, hold on. Let's just short circuit here and say, okay, let's do the and, right? And we'll say, not I not equal to j. Something crazy. Because so what this will mean was if j is not equal to I, which in this case that's true, this will be 1. Well, then we'll subtract 0. This will be 0. And then this will be 1 here. Right, I think that might do it. Am I crazy? So less than, this returns 0. Oh no, so this is wrong. Dang it. Okay, so what's going on here? So if this returns out to be 0, hold on, let's think. In this case, where I is less than j, this is 0 here. This is also, so this is 0, and we're going to evaluate this side here. No, because we don't want the parenthesis there. I don't think that is it either, because then evaluate this. No. So I is equal to j, that'll be 0. Okay, so we need to figure out if this side is also is this side is 1. Well, this side is 0. This number is 0 here. Oh, hold on. I think I might parentheses wrong. Okay, I gotta think this through. I is equal to j here. I is equal to j, which this evaluates out to 0. Let's make some comments. Okay. This is going to evaluate out here. So it's, the thing is I think it's trying to do this entire right side and compare that to this 0. Whereas we need to be subtracting 1. I don't even know what I wrote there. I can't even remember. So that goes out to 0. I is greater than j will become false. So that's a 0 for that little portion. Minus, is I equal to, not equal to j? Well, that's true, so that's 1. That'll go to 0. 0 and 1. So if I put 0 here, no, because it's doing this full side here, which make this goes to, in this case, 0 and 0 minus 1, not 1, so 0, 0 and 0, so that evaluates to 1. So this becomes 0 minus 1, which is negative 1. And so 0 and negative 1 well, we're getting out 0 here, so that's actually not right either. What's up, Primus? What's up, Social Gummy? How's it going? Appreciate you guys coming in. What's up, guys? So we would need to take this value, right? So this gives us a value of 0 and 0 in this case, for it being less than. Now we need to determine if we're going to subtract 0 or subtract 1. No. This comes out to 0, and this also comes out to 0, making this entire statement false. So 0 less than, well, are they not equal to one another? That's true. not true. So this is false. So 0 and 0 gives you a 1. So why are we not doing 0 less than the 1 here? So if this is 1 and 0, so 0, 0 minus, that's also going to give you 0. So no debugger? Do they have a debugger here? This is false. This is also false, making this entire statement false. Now we need to reduce it. Oh, hold up. The parenthesis goes there. 0. Oh. Oh, hold on. Let me make this 1 again. Oh, there we go. Did we get it? Okay, so if this goes to 0 in this case, this is 0. Well, this is true. 1 and 1. So this becomes 1. And so we subtract 1 from it because it is. Now if we do this, 2. They're equal, that's 1. And then if we did I is greater than 3, that's 0. Oh, we just, okay, we're close. So in this case, when they're even, this is true, this is false, meaning this is true. We're only going to subtract 1 if that's true. Oh, hold on. So we're only going to subtract 1 if I is less than j. That'll become true, making this overall true and subtracting 1. That gives us 1 for this. We did 3 here. That would give us 1 for this as well. If we did 1 here, that would give us -1. So what's going on when we're even and 1 and greater? So for even, this is true, this is false, making this overall true. This is false, making this 0, making this 1 minus 0, making it 1. So maybe we add I equals to j and short circuit it even further like this. No. That'll return back true for when it's equal. If it's not equal, we'll do this evaluation. So if it's not equal, though, that'll return 0 in both cases. So no, that's also not correct. Either return a 0 or 1 and subtract. So we just need to return a 0 or a 1 if there is a subtraction. So okay, got you. This will return 1 if that's true. So we just need to flip, I think, these. Right? So if it's greater than, we'll return 1 right away for true. If it is equal to, no. If it's greater than, it'll return 1 right away. It won't even go do anything. Okay? Well, what happens if it's equal? That's false. This is true. Minus, and so this, we want to do this. Take a parenthesis around that. Well, you're already determining if it's less than, right? And subtracting 0 or 1 from a value. So if it's greater than, what about just this? What about just this? If this is true, which in this case it's not, this is 0, minus this, right? Which is, so if this is 0, it would either minus, you would take away into the negative if even further, or you would return back the default, which means they're even. I think it's that. No? Is it just simple as that? Okay, they're even. 1. Oh, come on. Don't tell me I did it. No AI. So close. Oh. Ah, shoot. I thought I had it. Did I not have it? Ah, shoot. This should be -1. So in this case, I is less than j. So this is 0. Right? Minus -1, which would be -1. Oh, minus a positive. Oh, so we just need plus. No. So this evaluates to false. This evaluates to true. So this is 1. So it has to be minus still, sorry. That doesn't work. -1. 2, let's see it even. 0, oh, here we go, baby. Show me the money. Yes. Yes, Gabby, we did it. Oh, I'm proud of myself for doing that one. No AI. We didn't have to ask a question. Let's go. Okay, so I was overthinking it. Like, it really tries to, it sets you up for defeat here by preluding you with these combinatory logical expressions, when in reality, all you need to determine is, okay, are you greater than? That'll give you a 0 or 1 back. If you are, then you need to reduce by how much, either a 0 or by 1. Yeah, sorry, I'm really bad at explaining it, but it makes sense in my head. Let's go. We're gonna have to clip that one and repost that one to the channel. I'll have to go back and remix the stream and clip that one. Nice. Yeah, dude, it's always so much more simple than you think. It's always so much more simple than you think. But that's so annoying though. It gave you 8 problems in a row of using logical and or, and then it wrecks you here by throwing you this one, which is just pretty simple. But all it is, so I'm gonna try my best to explain this. If I is greater than j, this will be true, meaning this will be 1. So, and we want when I is greater than j to return 1. So we know that this value here is going to be 0, because if this is true, this is false. So none will be taken away, so we'll return 1 minus 0, which is 1, satisfying the I being greater than. Now, if it's equal to, where I is 2 and j is 2, well, this will be false, meaning 0. This will be false, meaning 0. 0 minus 0 is 0. Now, if I is less than, right, this is false, so this is 0. This is true, so this is 1, meaning 0 minus 1. Dude, how was I tripping up on this? This is so much easier than now that I know the answer. Like, how did I get stuck on this? Ah. How did I get stuck on this one? Now that I think about this was so simple. It's literally just, okay, 0 or 1 minus 0 or 1. The logic is trolling me. Okay. I think the stars meant that could be a little difficult. I'm not sure though. But it's already midnight, dude. I'm only on number 4. We're gonna have to break it up, dude. I've got work tomorrow. I'm gonna be screwed. I'm having fun though. Yeah, Blast, that's probably true, right? It kind of, you have to have like that specific, you have to kind of sort through all those cards of thought and find that right angle to go down, and we got it here. Oh, it feels good, dude. Feels good. Let's go. Now that I know it, it seems simple, right? It's like, oh yeah, no, like, if that's satisfied, you raise it to 1. I knew that you had to subtract somewhere. I just didn't know how to do the subtraction with the logical and or, because it was really tripping me up. The only way I was thinking about maybe doing it was like by like initially starting with the value and then decreasing it or something. But I knew that there was a way to do it with no additional memory. Oh, you did shifting. Or is that the right symbols? Placing there's no quickly showed on the chat. Oh, it's broken on chat. Oh. Oh, I is less than J. Yeah. Oh yeah, you can just combine these ternary statements together. Bunch of question marks, if else, if else, if else, if else, if else, else. Or then, sorry. If I, then this, else this. If I is this, if it's this, if it's this, if it's this. People actually use this kind of stuff in branchless programming to squeeze extra performance. Yeah, it would make sense, right? Like if you're really not trying to establish an additional variable or something, like you can come up with these little. Now it's interesting, right? If memory is super tight or something, I don't even know. Like you can't even establish one counter variable or something, or like an elif chain or something. You just want a simple, just 3 logical checks and 2 logical checks and a mathematical and 1 algebra. Really fast. And being C, it's really fast. Okay, let's quickly, we'll take a stab at number 5. Touch. In Java, got no idea about that. Compilers nowadays could convert branches to branchless, so I wouldn't worry about it. Interesting. Yeah, no, I don't even know what that means. I'm sure we'll get there sometime. Okay, let's keep pushing here. You guys are enjoying the stream. If you could leave a little like skis on it. Appreciate all the love. Thank you for coming in. Sylvia, Slow, Mang, all y'all are awesome. I've been watching you almost fall asleep 3 times already. I've been watching you almost fall asleep 3 times already. Oh, you almost fell asleep, Mang? Nice. Oh, those are, oh, okay, logical and or are branch operators. Like if commands. Oh, got you. If the following if statement legal? If n is greater than or equal to 1, less than or equal to, no, this is not legal. No, the statement is not legal. You need to use, I'll put your things in here. You need to use branch statement in order to compare to truthy / false, I don't know, falsy values or conditionals for a variable, something like that, right? Because this is not, it kind of looks like, oh, when I first started programming in Python, I thought that this was like solid. I tried to do this a lot, and I had trouble. I was like, why doesn't this work? But what's happening here is it's evaluating this condition, and then the result of that condition is then being evaluated against this condition. So this is going to give you either true or false, and then that true or false is going to be evaluated against a true or false. But that true or false is going to give you a return value of 0 or 1. So this, if n is, let's say, 1 in this case, well, n is greater than or equal to 1, because it is 1. So this evaluates to true. 1 is less than or equal to 10. Well, that is true, so this is true. But n is not between 1 and 10. N is 1, so that isn't true, right? Now let's say that n is like a big number, like 100. Well, this would be true, meaning that this is 1, and then this would be true. This would be true as well, right? But this would be false because n is 100, not between 1 and 10. So let's write what the actual correct would be. Oh, that's number. If so, oh no. So let's see. If so, what does it do when n is equal to 0? Oh, we already okay. So we'll say when n is equal to 0, right? When n is equal to 0, this evaluates to false, and then this evaluates to true. But n is not in that range. n greater than or equal to 1 is false, resulting in 0 being less than or equal to 10, which is true, resulting in the printing of the statement. But n is equal to 0, and so the statement is actually incorrect. So let's go include the standard io.h. We're going to go int main, and we'll avoid this bad boy. And we're going to say if, right? And what we'll say is if we want n to be greater than 1, so 1 is less than or equal to n, and n is less than or equal to 10. So if this is true, this will be 1, and if this is true, this will be 1, resulting in n being within that range, and we will print out this statement. N is between 1 and 10, right? Let me make sure I got this right. So n, if it's 0, this will result in false. Oh, hold on, I think I got this wrong. N is 5, or n is 0 in this case. This will be false. Meaning this overall is false, right? Because these both have to be non-zero values in order for this to be true. I often get confused thinking that, I don't get confused. I go back and forth, and I trick myself, thinking that this is that they both have to be the same value. But no, they both have to be non-zero values, right? That's the catch. It's not checking if they're both the same value or both 0 values. It's just checking if they're both non-zero values. Right. So we need to give a variable int n is equal to, let's say, 0 here. And we'll say else print f at n is not between 1 and 10. Boom, 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 boom. Let's see here, 5. Oh no. N is not between 0 and 10. 5. Oh, is it supposed to be? I think I misspoke. When n is 1, it is captured in there. I misspoke on my phrasing earlier when I first went over the problem, right? Because it is equal to, so because if n was 1, it would be in the range, right? Because it is equal. It is checking for that as well. My bad. I'm sure some of you guys caught me in the n is between 1 and 10. Beautiful. Hold on. Oop. I can't scroll back on the Twitch stuff, which is kind of annoying. Because it's just like yeah, I can't go back on I have no scroll on this window, unfortunately, so sorry guys. If we use oh, gotcha, you guys talking about branches. There's a branch in CPU level. Oh, gotcha. You also just talking about branches. Okay, cool. That was 5. I'm just gonna ask, can you clean up my words? The statement is not legal to compare two truthy falsy conditions for a variable. You need to use a branch statement. For example, when n is 0, the expression n is greater than 1 evaluates to false. Then 0 greater than 2 evaluates to true, which might incorrectly trigger the print statement. However, you need to use a logical and statement in order to compare two truthy / falsy conditionals for a variable. Okay, nice. Six is pretty easy as well. I'll do 6 really quickly. I might as well just do them all. Jeez. I'm never gonna get off here. Touch, chapter 6, exercise 6.c. We'll say No, the if statement is not legal. You are checking if n is equal to 1 less than 10, negative 9, not whether, not if n is in the range of values. Okay, if n is equal to 5, the print statement will not execute because 5 does not equal 10 minus 10, or 5 does not equal negative 9. Right? Is that correct? Yes. It's not a range check, it's just an evaluation. It's giving negative 9. If statement is not legal expression, so if n is equal to 5, the condition is false, and the printf statement will not execute. The if statement is not legal expression, n equals to negative 10. 1 by 10. Really like these backticks in here. It's not marked down, it's C. Okay. My headphones died. No! What does the following statement print if I? What does the following statement print if I has the value of 17? 17. If it's greater than, if I is greater than, okay, this was not that hard either. We might as well just finish these exercises. Touch number 7. Okay, so we'll go here and do include standard io.h. We'll go int main void. And then what we'll do is print f here %d I greater than equal to 0, then I else negative I. Okay, so the output will be we'll say I equals to 17 output, and they'll also say I equals to negative 17 output. Okay. So if I is greater than 0, which in the case of 17 it is, it'll print out I, which is 17. If I is greater than 0, which is false, it'll print out negative I. So negative 17, which is 17. Ternary operator at 17 also prints 17. Nice. The following if statement is unnecessarily complicated. Simplify as much as possible. Single assignment. If age is greater than or equal to 13. Teenager. I'm honestly, I'm pretty tired, you guys. Like, I'm pretty beat. Well, you're kind of multiplying a negative by a negative, right? Like, think of it, you're parenthesizing a negative on a negative. So negative one like isn't like inferred by the missing one there. Yeah. If age is greater than or equal to 13, and so if we're in this range, then teenager is true, else false. So we'll say teenager equals to um, you don't even need this, right? If you're not in this range, you're automatically false. You don't even need this else if false. So you only just need basically this, but you can change this to a ternary or to um, a okay, so right, you don't even need this because you're already being captured by this else. Um, for this overall range, you're just applying the else to both of these because right, it's like how the C scope thing works. So it would just be um, uh, if age less than if 13 less than or equal to age and age less than or equal to 19. Can we just say this? Can we go like this? So we need to include the standard bool.h header file. And then we would need to define this as a bool. and then we call to printf and do %bool. Is that how that works? How do you print a Boolean? This was section 5.2. We learned 5.9 again. How do you print a bool? Oh, so it's just a string that's converted to said string, a char star. Or you print out the actual value that's underlying the bool, which is an int, right? Which, in this case, it's saving it as an int. It's not saving it as quote true, quote false, right? It's saving it as true or false, the actual bool value given. And because we're saving it as bool as such, it will be as such. Okay, I think that'll work. I think that works. Let's get some feedback. Here's what I got. Oh. Ooh. Awesome, simplification is perfect. Oh, I don't have age, my bad. Let's say it's 15. My bad. I always forget to return 0. Yeah, teenager true or false, right? If teenager true or false, They're not doing any print here, so it's alright, no worries. Are the following statements equivalent? If not, why not? If score is greater than 90, print A. Else if score is greater than or equal to score is less than 60, print F. So less than 60, print F. Else if score is less than 70, print D, which would be greater than or equal to 60 but less than 70. I mean, logically, I feel like there's a trick somewhere, but I don't see anything that's like. I mean, it talked about like fall through, but that was for like the cases and like match case, switch case statements, right? That wasn't for these if else if chains, right? And they're not if statements deliberately, so they're not going to do their own checks and do multiple prints, right? It's only going to do one print in the entire chain. I think that they're equivalent. I mean, you're just going in the opposite direction and doing exclusion boundary that way, right? You're not including the boundary. So that one, you're 90 and above, else if your score is 90 and above, you get an A. If you're 90 and below, score is less than 60, it'll print F. Well, it's not less than, if it's less than 70. Well, hold on. A score of like, well, I mean, that'll work in both cases. A score of like 100 versus a score of like 50. A score in 100 going down on the left side would trigger the first statement. I think that, yeah, I think it is equivalent. The following function is equivalent. Why not? I think so. It's just going the opposite way with less than not. Yeah, this is perfectly equivalent, usually top-down approach because the ranges are mutually exclusive. The key is that the else is only triggered if all previous conditions were false. Yeah. Okay, open integrated terminal. Let's do a touch here for number 9. We'll say yes. These code blocks are equal. They just check the conditions in the opposite direction, and in doing so, to flip use between to greater than. In doing so, have to that's a pretty crappy explanation. These code blocks are equivalent. They just check the conditions in the opposite order, which requires switching this to this or vice versa. Logical and final results will remain the same. What output does the following program fragment produce? Assume that I is an integer variable. I is 1. 1 modulo 3. Well, 3 doesn't go into 1. So when you do that with the modulo, does it return back just the original value? Yeah, 1. So 1. In the case of 1, it'll print 1. But we don't break, so it'll print 1 and 2. Well, no. Let's go back up to those switch statements where I talked about that. Okay. Yeah. Because it's not like an if deliberately moves to the next code block. It just is a jump statement. It just jumps to that case and then we'll continue on the code. Right? So for this one, 10 here, what we're going to do is, what does the following output produce? So we'll do include the standard io.h header file. I'll go int main void. Open this up. We have int I is equal to 1. We have a switched case for I mod 3. We'll open this up. We have case 0 is printf for quote 0 quote. One, 2, over here 2, 1. So what will happen here is the output of this program will be quote 1, 2. Because I mod 3 or 1 mod 3 is equal to 1. But there is no break statement. So fall through happens in the jump after the jump statement. I think so, right? There's no break statement. Execution falls through to the next cases. There's no break statement, so fall through happens so execution falls through to the next cases.
You're not that guy, pal.
Hey, thank you.
Okay.
Camille, I appreciate the sub
Absolutely.
on YouTube. You're the boss. All right, cool. Last one here for the exercises. I didn't think we were going to finish them today, but looks like we did. Grinding, boys. The following table shows telephone area codes in the state of Georgia along with largest cities in the area. Write a switch statement who controls expressions is write a switch statement whose controlling expression is the variable area code. If the value of the area code is in the table, the switch statement will appear and the switch statement will print the corresponding city name. Otherwise, the switch statement will display the name message area code not recognized. Okay, this is pretty easy. Let's take this. Let's go here, print this. Let's do code. And we'll do like 229. And then we have switch for the code. Then we have case 229, which is going to be, quote, Albany. And then we'll copy these down. So we have Atlanta, Macon, Atlanta, Columbus, Atlanta, Savannah. Atlanta, Columbus, Atlanta, Columbus, Macon. Cool. This is going to be 404, 470, 478, 678, 706, 762, 770, 912. And then we have default printf to area code not recognized. So do we have to like call this switch statement, or we'll just hit it like in order here? I don't need that. Am I trolling? What am I doing wrong here? Missing terminating quote character. Quote, area code not recognized. Oh, is it? Oh, it wasn't wrapping. I thought it was wrapping the text. It wasn't a wrap. It was a crappy space. My bad. I thought it was text wrap. Okay. Oh, we even forgot our own thing. Dude, we just solved this problem. We still forgot. Are you trolling? Dang it. Come on, dude. Forgetting the brakes. My leg. Brake. My leg. Give me your best. My leg. And then I don't think we need a break after the default. No. Albany for 229. Why did I get like a... Oh, no, it's just the spacing. Cool, let me just do a quickly couple back sessions. Throw these in here real fast. Albany. I wonder, can you combine the... Oh yeah, you can. We can do like this. Case 470. Can we just separate these by commas? 678. I'm getting deja vu right now. So the Columbus would be 762. 770 again here for Atlanta. Albany 912. Does that still work? No. So how do you stack the cases again? It showed us an example here. Okay, you keep case like such. And then okay, so if we do that bad boy, Albany still works. Now if we hit, let's try 770 for one of these Atlanta codes that are nested in there. Atlanta, perfect. Woo! Yo, what's up, Wesley? All right, you guys, that is all of the... Unfortunately, there's no way to write a case label that specifies a range of values. There are some in the program, which isn't required to have a default case. If it's default missing the value, oh, that's for the reading. Whoops, I thought that was part of the problem. Awesome. www. That was a long one, guys. 3-hour stream today going over these 11 exercises in C. Um, it took us a little bit longer because we spent about 30 minutes on problem 4, which was a little bit of a brain teaser. That's 2. On it doesn't look like it, but this was a little bit of a brain treat, like a brain teaser, um, and it took us a little bit of time to kind of work through and think about. But so if you haven't seen this problem yet and haven't gotten, I know I'm showing you the answer, but go take a stab at it here. Forget what this answer, like let a couple hours go by and forget it, and then come back and try it. This one was fun. Um, I'm proud that we were able to work through this one without, needing to go get help and stuff. So we were able to brute force through it, just brain power. Okay, let's go ahead and quickly push up our notes here. Git add, git commit, finish chapter 5 exercises. Beesh. Oh gosh, thank goodness. All right, you guys, I'm done for tonight. I really appreciate you guys hanging out with me and joining me for today. Um, this was C Programming a Modern Approach, second edition, chapter 5 exercises, 1 through 11. So next time we'll come in and tackle these programming projects. There's quite a few of them. So we might have to break that one up. But next chapter is getting into loops. So we're really starting to compound the C material. I know we've already learned about loops and a lot of this stuff in our previous learning in Python and whatnot, but I'm trying to take the book at face value and what it gives us in like its kind of timeline. So I've been solving these problems with just the tools that it's given us so far in these first 5 chapters. But I'm excited to actually get into loops so we can actually make programming a little bit easier and do things automatically in C. So super excited. Thank you guys so much for being here and joining me. This was fun today. Please join the Discord link down below if you want to get access to everything from my notes, my videos, personal, everything's already on my GitHub and YouTube, but everything in my Discord is just kind of rounded up for you guys in there. So I'll see you guys later. Thank you guys so much for being here, and peace out. Later, y'all. Later, Blasto. Later, Slow. Later, Wesley. Peace out, y'all.